Hello everyone, welcome to our channel techlteworld. So our today's topic will be 5G call flow, that is eNB gNB dual connectivity. So let's start with the call flow. So first of all, what exactly the dual connectivity means. So dual connectivity basically enables the 5G service in existence with the 4G network. So that's why it's named as ENDC Dual Connectivity. So whatever the UV that will be the supporting ENDC can connect both LT and the 5G, that is a secondary node, and LT that we know as a master node, simultaneously at the same time. So in this case, as we know that our EPC that will be of 4G only, through which the UV will register. The UV will do the first registration through the 4G EPC only through the ENDC, and based on the UV supportability, it will go on reporting the measurement of 5G frequencies which are available, and the LTE nodeB will communicate with that secondary node, that is gNB, for their 5G-NR resource assignment, and the 5G-NR resource assignment is then signaled to the UV that which is supporting the 4G and 5G both, that is through the, or you can say the via RRC Connection Reconfiguration message. And after reconfiguration procedure completion, the UV will, as I already told you, the UV will now capable of connecting to both the networks 4G and 5G simultaneously. So now we will go through the complete call flow with whatever the message which are carrying. So as per the diagram, as per the call flow, we can see a UV which is supporting the LT and NR both, and the nodeB which we are telling as a master node. So first it will prepare the list of the PLMN that are supporting the 5G NR, and the message that will flow is like you can see here, SIP2 broadcast the presence of whatever the 5G NR PLMN is available via the PLMN info list R15. Through this, it will be providing all the 5G NR PLMN list, and after that the RAG process will start. You can see the random access preamble is sent by the UV to the master node B, and in response it's getting the random access response. So whatever the first message that you can see, the random access preamble is sent, so you will pick a random preamble here, and this having the ID, that is rapid, that is random access preamble ID, and each preamble transmission that we are talking about is associated with the RARNTI. Okay, so now this first random access preamble will go. Now there will be a response as a random access response. So in random access response, what actually UV will do? So UV will be gathering or listening on the PDCCH that is addressed by the RARNTI, and once the PDCCH that is associated with the RARNTI is decoded, the UV use the RBs to receive the downlink transmission block. So after this random access response, in message 3 it will be sending RRC Connection Request, that is message 3. So in this, the information that will be going from UV to master node, you can see that is uplink side channel CRNTI, the UV identity will go, and the establishment cause will go. There are a lot of establishment cards. It can be emergency, high priority access, empty access, MO signaling. So means this establishment cause carries this much of thing. So here the MO signaling will go, and the master node B then responds with the message 4, that is RRC connection setup. So RRC connection setup, that you can see this also carrying the messages CRNTI, and that will be in downlink shared channel, SRB identity, and DLUL, RLC modes, and PHR configuration, uplink power control. That also, these are in message 4, this information will be carrying there. And as a message 5, as we know, this is RRC connection setup complete message, that is message 5. So in this, it will be carrying the attach request, UV MRDC capability, that MRDC is the multi-radio dual connectivity, and the PDN connectivity request. So in message 5, this will be carrying this information, and this so here we can see that the master node B will be sending one initial UV message towards MME. So this is the NAS message, that is which will be signaled to the core network by this through this message only, and after that the MME will be sending the authentication request. So now here the authentication process will start. So after the authentication request, now you will be sending the authentication response. So in authentication response, it will be matching the AUTN and the XRES, that the NAS security mode command, which will be for go through MME to UV, and here the other security process will be got completed. So in this after that the UV will be responding of the completion of this NAS security mode complete. So here, up to here the NAS level security process will be got completed, and after that the MME will be sending the initial context setup request. So basically what MME here, the MME respond the eNodeB, that is a master node B with the few things, that is S1 AP initial context setup request, NAS attach accept, and activate default bearer request. So these three things will be you can say responded from MME to node B. So now we can see the initial context setup request. This carries the ERAB setup items, that is ERAB IDs, and already which I mentioned, that is attach accept, and it will be activating the default APS bearer. So after that the UV will be sent from master node B to UV. The message that will go is the UV capability inquiry. So here it will be UV will be inquired about the LTE and ENDC capabilities. So now the UV is responding with all the UV capability information, that UV capability RAT container list, that RAT type, what are the RAT types it is supporting, and now it is sending the capabilities like EUTRON NR, UV MRDC capability, that is multi-radio dual connectivity. It support the band list NR R15. So all this information that will be sent out by the UV to the master node B in this UV capability information. So after that, now this eNode B, that is master node, is sending all this UV capability info indication to the MME, whatever it got from UV. So that is got forwarded towards the MME. Now we can see that the master node, that is LT node B, is asking for the AS security mode command. So this is basically for the security between the node B and the UV. Here only from the both the directions ciphering is got enabled, and after that completion of the AS security mode, now the LT node B, that is master node, will be sending the RRC connection reconfiguration message. So here the EPS radio bearer identity, RLC mode, PDCP sequence number, all these things will be going through this RRC connection reconfiguration message. So now here after this message, after the RRC connection reconfiguration, which is also sent by UV to master node B, that is RRC connection reconfiguration complete, and then the master node B will be sending the initial context setup response to MME. So this basically contains the GTP tunnel ID, which is further used for sending the downlink data towards the eNodeB. So the main purpose of this is for sending the DL data. And now the UV sends the attach complete request to MME up to this message. Now here we are seeing that signaling MME will be sending for the modification bearer request, and it is after then signaling gateway is replying with the that the modify bearer response that is activated. And now the gNodeB will be acquiring the NR, PSS, NSSS, all the information through UV, and now the measurement report is getting sent by UV to eNodeB. So whatever the measurement report which I was telling before, that is after the default EPS bearer accept, so that all the miss results, miss ID, miss result, P cell, RSRP, RSRQ range, all the miss result of the neighbor cell, and the miss result of the neighbor NR cell. So all this information will be going in this measurement report. And after this measurement report, gNB addition request will be goes. SG addition request will be carrying a lot of information that we can see. It will be carrying all the EREP parameters, tunnel address, that is IP address, and TAID, use security capabilities, and all the keys which is related to this ngRAN node, and all the RAN mode, UV aggregation, maximum bit rate, and you can see a lot of cell group config, RRC connection reconfiguration, cell group, radio bearer configuration, measurement, measured frequencies of SN, that is a list of frequency it will be sending, and the SN gNodeB measurements, SN gNodeB configuration, that is all the UV capabilities and the coordination results, and the security information for SRB3. So a lot of information will be going through SG gNodeB addition request. So after this gNB addition request, there will be acknowledgement from the secondary node, that is gNodeB, to master node, that the PDU session resource admitted to be added list, PDU session resource not admitted list. So all these messages, and you can also see that SG node B to ME node B container, that is CG configurations. All this will be sending via this gNB addition request acknowledgement. So these are the list of the parameters and the information which will be going. So there are, if you go through more detailed in logs, there are a lot of information that will be going. But that is but that will be helpful if you go line by line for each and everything. So the video will be, you can say it will be too big video for to cover it. But here you can see what I have mentioned, like SG config. So SG config will be like carrying all the information related to the SGS cell group configuration. So that is basically for this, and DRX information, and misconfig of secondary node. All this information will be going through this SG config. And after that, RRC connection reconfiguration will be happening for 5G-NR bearer, that will be going from master LT node B to UV. So here also there are a lot of parameters, lot of information which is going, that is NR config, R15, ENDC release and add R15, secondary cell group information, which will here it will be going, cell group ID will be go, MAC cell group configuration, physical cell group configuration, and this UV identity, CRNTI, timers. So all the information will be going through this message. As you can see, like PMAX, UTRA, R15, radio bearer configuration of R15. So all this thing will be going in this particular RRC connection reconfiguration for the 5G-NR. And after the completion of RRC connection reconfiguration of 5G-NR from UV to nodeB, now gNB reconfiguration complete will be sent by master node, that is LTE, towards the secondary node, that is gNB. And then the status transfer will be also sent by LTE nodeB to NR node, that is gNB, that we are calling as a secondary node also. So up to here the SN transfer will be done. Now after this SN transfer, and we can see after this SN transfer, now we searching for the NR PSS, NRSS, NR PVCH. So all the synchronization will be, you can say radio level synchronization will be done here by the gNB. Now again the UV will be sending the NR preamble, not the LT preamble. So now NR preamble will go, and then the gNB will sending the PDCC DCI format 10, and after that the NR random access process response will go from gNB to UV, and NR MAC paid U, and after that the DCI PDCC DCI format 00. So this is basically now the call flow. Now the secondary node is getting added. So this is the messages for the NR basically. So we can see here the PDCC DCI format 10, why it is going. So this DCI format 10 is used to assign the, as you know, that this is for the downlink resource, and as you know that DCI 008 is used for assigning the uplink resource to the UV, and this can be scrambled from CRNTI. So now the UV will be sending the dual connectivity PHR maxi and the measurement report. In measurement report it will be sending the miss result of the neighbor cell list of NR, PCI of NR, miss result of miss result cells. So this will be sent in the measurement report, and after this the LT node will sending the RRC container that will be containing all the 5G measurements. And now the secondary cell will be responding with the secondary RAD data users report, that is the what are the ERAB users reports are there. So that will be sent by the secondary node, that is gNB, and the gNB status indication. So that will be the gnode overload information will be go through this message. So in total here we can say that after this, now it will be both the dual connectivity got activated up to this messages. So for the as I have already told you, for going much more deep into this, it will be the big video. So I will be writing already. I have one article on our website techlteworld for this 5G NR call flow. So please go through that, and thanks for today. and please let us know whatever the things need to be added, and whatever if there will be any mistake or which need to be corrected, or any extra information that need to be added, please let us know. Thank you.